Okay, so in this video, we're going to look at vectors versus scalars. Okay, these are very important in physics because all of our quantities that we're going to talk about fit into one of these two categories. So a scalar quantity is a quantity in physics that has magnitude or size only, right? So scalar is magnitude only. So if you look at a number, it's the number itself. And so in physics, some of the basic examples, speed, time, distance, okay, are going to be examples of scalar quantities. Energy is also another quantity, is another scalar quantity. Now, on the other hand, vector quantities are quantities in physics that have magnitude and direction. So they have to have the size plus the direction. Okay, and there's multiple ways that we can represent directions. For the most part, we look at arrows, okay, especially if it's a picture of it. But we also look at north, south, east, west, right? And the most common is plus or minus, positive or negative, okay? So velocity, displacement, acceleration are examples. Forces are another example of vector quantities. And then what we can do, again, we can just represent vectors just in different ways. And one way is by using an arrow, okay? And so here is an example or just a quick little picture. So if I just say 45 kilometers per hour, that's a speed and it's in scalar, okay? Because it doesn't tell us which direction it goes in. So if you look at your speedometer on your car, that's you're given the speed because it doesn't give you the direction, okay? Now, if we want to talk about a velocity on the other hand, velocity is a vector, which means direction is also included. So I'm saying 45 kilometers per hour, right, at an angle of 40 degrees, okay? And so that makes it now a vector versus a scalar, okay? And now here's how we represent vectors. We just use an arrow. So the magnitude or the length of the arrow gives us the magnitude, okay? And then whichever general direction that the arrow is pointing, that is our direction. You could be given an angle. You can say northwest, northeast, east, west, whatever, okay? But there are two special points, the head and the tail, right? And so this is like the arrow head, and this is the tail. Because when we do vector addition, vector resolution on that, we always look for tip to tail or tail to head. Sometimes we'll refer to this as the tip of the arrow, okay? And so we may say, hey, place them tip to tail. That means you're going to take the tip of one vector and place it to the tail of the other vector. So that's just the difference in what a vector versus scalar is. Now the rest is we're going to look at the mathematics of vectors. The first thing is vector resolution. Okay, so vector resolution helps us because we break down components, or we break down the vector into components. Okay, so we break them down into horizontal and vertical. Okay, how do we do that? Well, we're going to use some basic trig. So we're going to say that horizontal is going to be a cosine theta and our vertical is going to be a sine theta. One thing to note here in physics is that we always measure from the horizontal, not the vertical. There's a very few cases where we would measure from the vertical, but if that happens, we just simply flip the sine and cosine, right? So cosine goes to y and sine goes to x. But just right now, we're going to go x cosine, y sine, okay? So here's an example. It says at a ski resort, you take a tow rope to the top of the bunny slope. Your displacement for this trip is a length of 190 meters and points at an angle of 26 degrees above the horizontal. During the ride to the top, how far have you gone in the horizontal and vertical directions? Well, simple enough. We're going to say AX is equal to A cosine theta. AY is equal to A sine theta, right? And so we're going to say our A will be 190 meters and our angle will be 26 degrees. Now, make sure your calculator is in degrees, not radians. If you're going from math to physics, physics to math, you're probably going to have to change that. So we go 171 meters horizontally. All right, so if our tow rope does this, that means I've gone 171 meters this way, right? And it's 190 meters, and this is 26 degrees. Okay, now my vertical, I'm doing 190 sine 26. And so I just go in and change my function. And that's going to tell me 83.2 meters is how far I go vertically. So this would be 83.2 meters. Okay. Now, if I'm given these pieces, right, that's what we call vector addition. And so let's look at that. So there's going to be a few ways to add vectors. Now, if they point in the same direction, meaning they're both vertical or both horizontal, you just simply add or subtract the magnitudes, right? So it's just like adding, subtracting numbers. And then the direction will be in the direction of the largest value, especially if they're going opposite ways. If they're right angles to each other, then you just simply use Pythagorean theorem, right? And so when you use Pythagorean theorem, what you can look for is what is called the resultant vector, okay? And then you use the inverse tan function, right, to find the angle. So theta equals tan inverse of your y component over your x component. Again, by doing y over x, that gives us our horizontal angle. And you could just do a positive, and you could just say below the below x in some way. Okay, the positive and negatives just kind of tell you where they are, because we don't want to do all that math stuff of saying, okay, if it's in the second quadrant, we know it has to be between 90 and 180. If it's in the third quadrant, it has to be 180 and 270, right? We just simply say in the below positive x, above negative x, right? So something like that. Now, if they're not at right angles to each other, this is where you get more involved, right? So the first thing you have to do is resolve the vectors into components, add those components. Okay, that's going to give you the components of the resultant, and now you have Pythagorean theorem, right? So it's like you have to do the previous slide, add them by using this method, and then to put it all back together, then you use Pythagorean theorem and the inverse tangent function. Okay, the last way, but is rarely tested, is to add the vectors graphically. Okay, where in this case you're going to place the individual vectors tip to tail or tip to head, right? Whichever word you want to use. And the resultant is drawn from the tail of the first to the tip of the last. So if I have to add two vectors like this graphically, this is my tip to tail, right? And my resultant goes from the tail of the first to the tip of the last, okay? And so this would be my R. All right, so here's an example. So you cut a piece of plywood to make a skateboard ramp. The ramp will cover a horizontal distance of 1.33 meters and rise 0.380 meters. What are the required length of the ramp and the angle that the ramp makes? Okay, so picture-wise, it does this. Sorry, that should be a 90-degree angle. How you find the third side of a right triangle? Pythagorean theorem. So it's 1.33 meters, 0.380 meters, right? And so I'm going to do c squared equals a squared plus b squared, or c equals the square root of a squared plus b squared. And it's going to be the square root of 1.33 squared plus 0.380 squared. And so it'll be square root of 1.33 squared plus 0.380 squared. And that's going to give me a length of 1.39 meters. Okay, so that's how much it's going to cover. And then the angle that the ramp will make, you say theta equals the inverse tangent of y over x. So it's going to be theta equals the inverse tangent of 0.380 over 1.33. Okay, again, that's going to give us our horizontal angle. So I'm going to say inverse tangent 0.380 divided by 1.33. And it's going to give me an angle of 15.9 degrees, approximately. Okay, so this plywood or sheet of plywood will go 1.39 meters at an angle of 15.9 degrees. Now, here's one where we would add in terms of a displacement. So when you get something like this, my recommendation is to draw a chart. Right? And so basically you have three vectors in this case and the resultant. So there's my resultant. This is my x column. This is my y column. So I get A, B, C. Right? And so I'm just going to write this A is going to be A cosine theta. AY is going to be A sine theta. So I'm going to do that for each one of these vectors, right? So I'm going to do this here for each one of those vectors. I'm going to say 2.65 cosine 140. Now don't forget the negative sign here. 2.65 sine 140. So 1.70. And then I do the same thing for the next one, 4.77 cosine 252, negative 1.47. And then 4.77 sine 252, negative 4.47. And then 3.18 cosine 332, so 2.88 or 81, sorry. And then 3.18 sine 332, so negative 1.49. And now I add my x pieces, so negative 2.03 minus 1.47 plus 2.81. And so I end up in the negative x direction of 0.69 kilometers. And then I do 1.7 plus negative 4.47 plus negative 1.47. And I end up with negative 4.24. So what that means is if I start here, that means I'm down in this direction somewhere, right? Something like that is where I end up. Okay. And so now I've got my components. These are the x and y components of my resultant. So to find my resultant, I simply now do Pythagorean theorem. Be careful when using your calculator to put the negative in parentheses, or simply just do the positive, because when you square numbers, right, you do negative times negative, you end up with a positive. So this is going to be a resultant of 4.29 kilometers. And now I do my inverse tangent function. So inverse tangent of negative 4.24 divided by negative 0.69. Again, I'm using the negative signs, but when I plug into my calculator, because negative over negative is a positive, I can just put in the positive, and I have to indicate where I'm at. So 80.8 degrees below negative x-axis. So I should over here. This really should be over here. Okay. So this is like 0.69 meters. This is 4.24 meters. And this, the length of this arrow, right, are those two answers right there. Okay. So again, vectors, vector resolution, vector addition is very important.